Hi guys, welcome back to Math with OG. In this video, we'll be looking at basic operations with fraction. That means how do you add, subtract, multiply, and divide with fraction. Like I always say, understanding maths or doing good or better in mathematics can only be achieved when you know the basics in mathematics. You must have come across questions where the solutions are looking tricky to you. It's just because the basics, you have issues with the basics. So if you want to be very good in mathematics, it is very necessary you understand the basics in mathematics, and that involves basic addition, basic subtraction, basic multiplication, basic division. How does fraction behave? How does decimals behave? When you understand all these things, in essence, I'm just trying to let you know that when you understand mathematics in primary school level, there is 100% probability that you will do well in mathematics when you understand primary school level mathematics. Now, how do you add? How do you multiply? How do you divide? How do you subtract in fraction? Now, let's start with addition. We'll be using this as examples to explain. For addition and subtraction, they follow exactly the same rule. So if I have a fraction like this, a over b, I'm working with plus or minus. That means it can be plus, it can also be minus, c over d. You can only add and subtract two fractions when they have equal denominators. So when they have equal denominators, you simply add the numerators together or you subtract the numerator together. Now, remember in our last video, we looked at arranging in ascending and descending order, and I taught you how to make two fractions have equal denominator by simply looking for the LCM of the two fractions. Now, if I ask what is the LCM of b and d, assuming b and d are numbers, is simply b times d. So I can put here the LCM of b and d as bd. Now you ask yourself, how many times will b go into bd? B will go into bd, d times, then d times a will give us a d. Then you have plus or minus. That means either you are working with plus or you are working with minus. D will go into bd, b times c will give us what? bc. So in essence, ab is the same thing as ad over bd, because I simply multiply this guy by d to get this denominator. So I have to multiply the numerator by d to also get this numerator. Similarly, I simply multiply this guy by b to get this denominator. So I have to multiply this guy by b to also have this what? Numerator. So this is how you add and subtract fractions. Now using this guy as the first case study, you have 3 over 5 plus 2 over 5 minus 1 over 5. As you can see, equal denominator. That means I can add and subtract at will. So I can just put here 5. So what is 3 plus 5? 5. What is 5 minus 1? 4. So the answer here is simply 4 over 5. As easy as that. So that's for addition and subtraction. Now, what about multiplication? In multiplication, whenever you are given a fraction like this, a plus b multiplying c over d, you simply multiply the numerator together and also multiply the denominator together. So you should be having something like this: a multiply c all over b multiply d. So you can go ahead and just multiply all through, keep your answer, multiply through and keep your answer. Or if you see a common factor from any number in the numerator and a common factor from any number in the denominator, you can simply cancel out. That means in the process of solving, you are getting 8 multiplied by 9 all over, let's say, 2 multiplied by 11. As you can see, there's a common factor between 2 and 8. So I can say 2 into 2, 1. 2 into 8 is 4. So what common factor did I use to divide these two guys? Is simply what? 2. Because 2 can go into 2 the same way 2 can go into 8. So if there's something common, you can cancel out. If there's nothing common, simply a times c, ac, b times d, bd. Now let's use that approach to solve 3 over 8 multiplied by 2 over 5. 3 over 8 multiplying 2 over 5. So I can say this is 3 multiplied by 2 all over 8 multiplied by 5. I can express this numerator and keep the answer here. Also express this denominator and keep the answer here. Then check if there's anything common and cancel out, Or from here, I can simply say that 2 here 1, 2 into 8 is 4 because 2 is common to 2 and 8. So I will not do, or I will do 3 times 1 to be 3, 4 times 5 to be 20. So my answer is 3 over 20. So what is the other approach that I mentioned? I said you can simply solve like this: 8 multiplied by 5. Go on and multiply without cancelling out. 3 times 2 is 6. 8 times 5 is 40. At this junction, this is not a simplified answer because this is not this fraction in its lowest term. So 2 can cancel out. So I can say 2 here, 3, 2 into 40, 20. So you can see you are still getting your 3 over 20. So in fraction, you can only cancel out numerator and denominator. You can't cancel out numerator and numerator, and you can also cancel out denominator and denominator. Now the next question, division. Next question is division. Whenever you are given fractions in this form, a over b dividing c over d. In mathematics, there's something we call reciprocal. There's something we call reciprocal, and the same thing as the multiplicative inverse. We'll look at multiplicative inverse when we get to binary operation. The reciprocal of a number is simply inverting the number. That means change the numerator to the denominator and also change the denominator to the numerator. So if I ask you, what is the reciprocal of 1 over 2? The answer is simply what? 2 over 1. The reciprocal is 2 over 1. What is the reciprocal of 5 over 3? The answer is 3 over 5. So whenever you are doing division, what you simply do is change this sign here to multiplication, and after doing that, you invert this fraction. Change this sign to multiplication and invert the fraction after the division sign. So you have no business with this fraction because this fraction is before the division sign. So the fraction after the division sign will be inverted when this guy is changed to multiplication. So a over b dividing c over d is simply a over b multiplying d over c. Now you can simply do a times d, that is ad, and b times c is simply what? bc. So that's that for that. Now let's move on to this question. You have 7 over 12 dividing 14 over 21. 7 over 12 dividing 14 over 21. At this junction, I cannot cancel out anything. So I have to first of all change this guy to multiplication sign and inverting this fraction. So this will give us 7 over 12 multiplying 21 over 14. Like I mentioned here, you can choose to multiply, start cancelling out. But since we've done this already, so I can use a different approach for this. So instead of you to multiply before you start cancelling out, the way the question is in this form, you can simply use numerator to cancel out denominator. Use numerator to cancel out denominator. What do I mean? If there's anything common between 7 and 12, you can cancel them out. If there's anything common between 7 and 14, you can cancel them out. If there's anything common between 21 and 14, you can cancel them out. And if there's anything common between 21 and 12, you can cancel them out. So you only have business with the numerator and the denominator. So I can say here, 7 here 1, 7 into 14, 2. Now something is still common with a numerator and a denominator, and that is 3. 3 here 4, 3 here 7. Now at this junction, you can't say 2 here 1, 2 here 2 because 4 and 2, they are at the denominator. But if there was something common between 7 and 2 or 7 and 4, you can still cancel out. So as you can see, nothing can cancel out. I'm left with 1 and 7 for the numerator, and I'm left with 4 and 2 for the denominator. So I'll write here 1 multiply 7 all over 4 multiply 2. So this will give us 7 all over 8. So that's the answer to the question. Now the next question. We are given 5 whole number 6 over 12 plus 3 whole number 1 over 6. Whenever you are given question in mixed fraction, you can solve it using two ways. One of the methods, convert to improper fraction. We've done that already. Convert to improper fraction, then you add. The second method is simply add by adding the whole number part and adding the fractional part. So before we proceed to adding the whole number part and fractional part, note that a fraction in the form a whole number b over c is equal to a plus b over c. I repeat, a fraction in the form a whole number b over c is equal to a plus b over c. So what do I mean? 5 whole number 6 over 12 is the same thing as 5 plus 6 over 12. So if you add up these two guys, you are going to get 5 whole number 6 over 12. So let's check for confirmation. 5 is the same thing as 5 over 1, and this is the same thing as 6 over 12. The LCM here is 12. 1 into 12 is 12. 12 times 5 is 60. Plus 12 into 12 is 1. 1 times 6 is 6. 60 plus 6 is simply 66 all over 12. Now, 12 into 66 can go 5 times. So I'm converting improper fraction to mixed fraction. We've done that already in our previous videos. 12 into 66 can go 5 times with a remainder of 6. So I have a 6 over 12. So this is 5 over 6 over 12 being equal to 5 plus 6 over 12. So therefore, 3 number 1 over 6 is the same thing as 3 plus 1 over 6. Now, during my solution to this question, or if I want to solve this question, I won't even solve with 6 over 12 because there is something common to 6 and 12. Solving with 6 over 12 will give me a correct answer, but I don't want to solve with 6 over 12. So I'll change this guy to 6 here 1, 6 here 2. So 5 whole number 6 over 12 is the same thing as 5 whole number 1 over 2 plus 3 whole number 1 over 6. So this is what we'll solve, which is the same thing as 5 number 6 over 12 plus 3 number 1 over 6. Now, since I just mentioned that 5 number 6 over 12 is the same thing as 5 plus 6 over 12, okay, let's bring this to the other side. We have 5 1 over 2 plus 3 1 over 6. I can change this guy here to 5 plus 1 over 2 plus 3 plus 1 over 6. Makes more sense. So I can now add the whole number part. This is better than converting to improper fraction before solving. Add this whole number part to this whole number part. 5 plus 3 is 8. So I have 8 plus 1 over 2 plus 1 over 6. So this will give us 8 plus LCM of 6 and 2 is 6. We know how to do that already. 2 into 6 is 3. 3 times 1 is 3. Plus 6 into 6 is 1. 1 times 1 is 1. So this is 8 plus 3 plus 1 is 4. 4 over 6. 2 here 2. 2 here 3. So we have 8 plus 2 over 3. Remember I told you that a whole number b over c is the same thing as a plus b over c. So a plus b over c is the same thing as a whole number b over c. So 8 plus 2 over 3 should give us 8 whole number 2 over 3. So that's the answer to that question. Over to the next question. Over to the next question. We are given 3 whole number 4 over 9 minus 2 whole number 5 over 6 to solve. Now I want to follow the same approach by not changing to improper fraction. Following the same approach by not changing to improper fraction. Now this is the same thing as 3 plus 4 over 9 minus, remember to open your bracket. In our next video, you will understand why bracket is very important when working with minus sign when we look at BODMAS. Now we are going to have a minus 2 plus 5 over 6. Without putting this bracket here, you will make a mistake of writing minus 2 plus 5 over 6, which is actually wrong, because this minus sign is affecting the whole number part and also affecting the fractional part, hence the bracket. So this should give us 3 plus 4 over 9 minus 2 minus 5 over 6. Now add the whole number part and add the fractional part. So 3 minus 2 is 1. So I'm left with plus 4 over 9 minus 5 over 6. So this will give us 1 plus LCM of 9 and 6 is simply 18. 9 into 18 is 2. 2 times 4 is 8. minus 6 into 18 is 3. 3 times 5 is 15. Now 8 minus 15 should give us a minus 7 over 18. Minus 7 over 18. Whenever you get to this junction, this is one of the reasons why most people always convert to improper fraction when solving subtraction, because when they get to this junction, it automatically becomes difficult for them to solve. Now 1 is the same thing as 18 over 18. 1 is the same thing as 18 over 18. So I can change this 1 to 18 over 18 so that I can have the same denominator with this guy. Then you have a minus what? 7 over what? 18. So this will give us what? 11 over 18. So that's the answer to the question. Cases where you are solving, cases where you are solving, for example, you get to a point where you are having 8 plus minus 7 over 18, for example. There's no need changing this guy to have a denominator of 18. Just remove 1 from 8. If you remove 1 from 8, that 1 will leave here as 18 over 18. Pay attention. If I remove 1 from 8, that 1 will leave here as 18 over 18. So I'll be having something like this: 7 plus 1. That's for this 8. Then remember, you are still having a minus 7 over what? 18, because plus times minus is simply what? Minus. So this one here will change to 18 over 18. So if I remove 1 from here, it will change to 18 over 18 here. So I'll be left with 7. Remember, you are having a 18 minus 7 over 18 with this positive sign, because this one is changing to 18 over what? 18. So your answer will be what? 7 plus 11 over 18, which will give us 7 whole number 11 over 18. As easy as that. So whenever you subtract, you have a negative sign, you remove 1 from the whole number part, and that whole number part will go to the numerator as the value of the denominator. So you are solving, you have something like this: 7 whole number, you are having a 2 minus 17 all over 17. You are well aware that this will give you a minus 15 over 17. So what will you do? Remove 1 from here, so you are left with 6. That one will come here as what? 17 over 17. So you'll be having a 17 minus 15 all over 17. So this will be 6 whole number 2 over 17. As easy as that. Now back to the last question. 5 over 8 multiplying 1 whole number 3 over 5. 5 over 8 multiplying 1 whole number 3 over 5. Now, on no account will you do any operation or will you do any calculation under multiplication and division with mixed fraction. On no account should you try that. So whenever you have multiplication or division with mixed fraction, always change the mixed fraction to improper fraction. So let's do that together. This will give us 5 over 8 multiplying 5 times 1 is 5, 5 plus 3 is 8, 8 over 5. So this is 5 over 8 multiplying 8 over 5. 8 here 1, 8 here 1, 5 here 1, 5 here 1. So this is simply 1 times 1 over 1 times 1, which will give us 1 over 1. So the answer is simply what? 1. So that's the answer to the question. That's that for operations with fraction. Don't be scared. At a particular point in time, we'll be answering questions based on everything we've learned. So for now, what I'm doing is to explain each topic. Then when we are done or when we've covered a lot of topic, I can now go back and start answering as many questions in each topic as possible. There will be a segment where we answer all the questions in a particular topic in Waec, answer all the questions in a particular topic in Jamb. There will be time for that. But for now, we are focusing on educating everyone on each particular topic. So in our next video, we'll be looking at board maths proper. So what do you do when you have multiplication, division, addition, and subtraction all scattered in an expression, be it with fractions, be it with decimal, and be it with whole numbers? That's what we'll be looking at in our next video. Board maths, how do you apply board maths? So thanks for watching this video. Kindly use the like button if you actually enjoyed the video, and don't hesitate to comment if there was any error in our calculation or if there's any question you wish to ask. Also, don't forget to subscribe if you've not done that already. and use the share button to share to other people that you know will need this video. Thank you once more. See you guys in our next video.